Solve equations. Quadratics. Hello friends, the entire idea of this video is to solve a quadratic. And what does that mean? It means when I solve a quadratic, I'm asking the question, where does y equal 0? Where does y equal 0? And inherently, on a graph, the best place to look is where y equals 0. So I'm looking at my y-axis right here, and at the 0 point, we realize that the entire x-axis is y equals 0. And therefore, when we are saying solve a quadratic, we are saying at what point, boop, boop, does our parabola actually hit the x-axis, aka y equals 0. Some of these are simple ones. If you just have one on each side, meaning I have an x squared on one side of the equal and I have a number on the other, well, this one's just one, square root done. And we are literally taking this and we are square rooting. I end up with x equals plus or minus 5. Again, class, I am not going to be a stickler about the plus or minus, but I am going to put it on there in this video because I don't want a bunch of nerds commenting. But this is it. If we have one on each side, we're just square rooting, which is the opposite of squaring, and getting our answer that way. While I did attempt to make some rhymes, they can't all be gold. And this one says, got to isolate the x squared using algebra and then square root done. They can't all rhyme, I'm sorry, and it's true. But in this case, I'm saying got to, meaning I've got 2 over here. I've got an x squared, and I've got a normal number. Notice there's no x. We have to remember that x and x squared are different animals, okay? So in this one, I'm going to just use normal old algebra, but I need to isolate my x squared. So therefore, I'm going to add 18 to both sides. I'm going to add 18. I end up with 2x squared equals 18. I'm going to divide by 2 because, again, I want x squared all by itself. I end up with x squared equals 9, and there, we did it. We're back to just 1, square root done, and I end up with x equals plus or minus 3. Boom! The third type is standard form, and in standard form, we're just not there yet. We have to do factoring. We need to use our strategy so that we can pull this x out of there. So see the difference between this one and the second one? The second one had an x squared and a number. This one has this pesky x in the middle. That ruins the whole thing, so don't worry about it. Now we're at root form, and the rhyme is root form stopping ye, used the zero product property. And what this means is I've got my root form. I've got x plus or minus something times the quantity x plus or minus something. Well, this looks way more confusing than it is, and I'm going to use a strategy called samurai chop. And the zero product property tells me that if 2 things are multiplied together and they equal 0, well, then one of them has to be 0, or both of them could be. So when I chop this, what I'm really doing is I'm taking x plus 1 and saying, what if that was the one that equals 0? And then I'm also taking x minus 2, and I'm saying, what if that was the one that equals 0? And then I'm solving for both. I'm going to subtract 1, and I get x equals negative 1. I'm going to add 2 on this side. I'm going to get x equals 2. And that's it. Remember, when you solve a quadratic, you could have 2 answers. That's where the parabola goes through the x-axis, dips down, and then comes back out and hits the axis again. You could have 1 answer. That's where the vertex is on the x-axis. And then you could also have no answers. And this is where the vertex of the parabola is just above or below the x-axis, and that means you don't have real answers, which will then involve a imaginary number. Now, what would we do with vertex form? So standard form, we're going to need to factor. Root form, we're going to samurai. Vertex form looks a little harder than it is, but it's got all the things we need for solving it algebraically. Now, your gut instinct is going to tell you, oh, if I distribute this, no, stop it. No distributing. Got it? Don't do it. It's not going to help you. First, we're just going to think about this very concisely and algebraically. I'm going to subtract 3 from both sides. Now, fair warning, this answer is going to be ugly. I get 2x plus 1 squared equals -3. And now, you're going to want to distribute again. And I must yell at you, stop, no distributing. I'm going to divide both sides by 2 because I want to get that x all by itself. I end up with, I'm going to go over here a little bit, x plus 1 squared equals -3 over 2. God, I said it was ugly, and it's going to be. Now that we have the next thing going on is squaring it, I'm going to square root this whole thing. And I end up with x plus 1 equals the square root. And again, hideous numbers. Mr. B would never give this to you on a test. -1, -1. And let's just scribble this out because I'm pretty much out of room. And that would be my answer. It is not pretty, but it is a number, sort of. It's imaginary, but it's still sort of a number. Anyway, that's how we solve quadratics in this class.